When we're looking at the nose, we're going to do the sense of smell first. So you have a person's nose here, and we know that the nostrils are only a really small part of the nasal cavity, and the nasal cavity opens up and it keeps going down until it actually meets the throat. So we got that small little opening, and here's your throat. I'm going to move that up just a wee bit for a second. So here's your throat, and it goes down. Now, what we're actually interested in here, all right, is this area here. What ends up actually happening is every time you inhale air through your nostrils, not only are you filtering it and cleaning it and warming it and moistening it, but whatever is in the air is passing through your nasal cavity. And just above, at the top of the nasal cavity, you have an area right here of nervous tissue and sensory receptors. And these sensory receptors, we'll just draw them differently here. Okay, so there's one there. It's a weird looking blue. There's another one right next. Well, actually, there's a lot. And we'll draw another one here. Okay, so as air particles come in through the nostril, these little particles will actually attach to these sensory receptors. So let's say this is a little smell particle that actually carries the compounds in it that are released when you take muffins out of the oven. Well, those little scent molecules will attach themselves to the sensory receptors at the top of the nose. And those messages will create, those sensory receptors will create actual messages. And those messages will turn into nerve impulses that will go to the olfactory region of the brain and get processed. It's very much tied into memory, because once you smelt something, you've identified that smell, it kind of sits in your database of smells. Now, if you're sick, okay, so let's erase these. Let's assume that these things are still here. Right here. Actually, we'll go with this blue. Right here. Now, let's assume that you are ill. So you've got some mucus. Okay, we'll draw the thickness here. And let's assume that you've got some mucus that's lining your nasal cavity. You're like me and you've got a sinus infection. So when the air actually comes in, the mucus is covering these actual sensory receptors. So when you're sick with a cold or a sinus infection or something like that, and your nose is plugged up, you often don't taste as well. Because when you actually taste food, okay, when you're savoring food, 90% of that is messages from your sense of smell. If you plug your nose and you try to drink something or chew something, well, you're not going to taste it as much. In fact, when kids have to take medication and the medication tastes really bad, doctors will often suggest that children plug their nose as they're swallowing. This lessens the taste. Does that make any sense? I hope so. Now, if we look at drawing a tongue, let's look at your sense of taste. Let's say this is your tongue as a whole. We'll notice that, the word now is more or less that there aren't really specific regions on your tongue that have only these taste buds or these sensory receptors, but rather there's a higher concentration in these areas of these specific taste buds. The taste buds as a whole are all over the actual tongue, but there's a higher concentration of certain tastes in certain areas. Okay, so at the forefront of the tongue, okay, at the beginning of the tongue, we have our sweet area. Okay, so this is number one. Number one is sweet. So a lot of the taste buds that are at the tip of your tongue there's a higher concentration of those that will actually taste, that will actually get excited when sugary or sweet molecules sit on the tongue. And then we have the next one here, which is the opposite of sweet, salty. Okay, salty ends up kind of being from about here to about here. This is number two, and this is salty. Okay, now again, they're all over the place, but there's a higher concentration of them, okay, in these areas. Next, we move on to sour. And sour, all right, ends up being in these areas. So things like Sour Patch Kids and those kinds of kind of acidity sort of high foods will get more or less tasted on the sides here. So this is sour. And then finally, at the back of the tongue, we have our bitter tasting stuff. So this is 4. Okay, this is bitter. And, there's some textbooks that'll say that this middle area either doesn't have a lot of taste buds, or that is kind of where this umami taste bud, like a higher concentration of that goes. I'm only expecting you to know these 4. Okay, I'm not necessarily expecting you to know the rest. I do expect you to know that chemicals in the actual food we eat, as you're masticating and chewing and moving it around the mouth, some of these chemicals, these little molecules, will sit on the surface of the tongue, and you have very small receptors there. And those receptors will get triggered, they'll get excited by certain types of molecules to help you identify what it is that you're eating. Now, over time, we lose taste buds. This is one of the reasons that kids don't like bitter tasting food when they're younger, but are able to take it when they're a little bit older, as young adults or adults, because they have less taste buds. The food is not as overpowering. Things like smoking, drinking alcohol can ruin taste buds. Eating a lot of hot, spicy food can ruin taste buds. Eating a lot of hot temperatured food. So if you've ever burnt your tongue drinking too hot chocolate or tea or coffee, okay, these are things that can damage your taste buds. And as you age, your taste buds, you get less and less of them. It's one of the reasons that food for elderly people in old people homes, I guess, or geriatric residences, tend to have not as much taste or spices in them, because older people cannot necessarily taste as well as young people.